This video will show you how to use the Onset Hobo plug load logger, the UX120018, as both an energy meter and also as an energy logger. The device is designed to work on 120 volt AC pluggable loads to a maximum capacity of 15 amps.
We have our plug load logger here on the bench, and we're going to show you how to use it as just an energy meter without launching it in HoboWare. Certainly, if you need to record data, historical data over time, you will need to launch it, configure it and launch it using either the free version of HoboWare or HoboWare Pro. But you can also just use it as an energy meter or energy display. So we're going to connect, first we're going to connect up our line power. To the right side of the logger, we have a line cord that's already plugged in. So now we have it plugged into line power. We can see what the voltage is. We don't have a load on it, so that's all we see. Our load is going to be a 3-speed fan. It's a fairly new fan, so it's pretty efficient, but it'll give you an idea of how things are displayed. Notice at the bottom of the LCD screen, it says meter. If this was configured in logging, if you used HoboWare to configure it, it would say logging. So let's plug in the fan. Our fan is plugged in, but it is not turned on yet. And let's turn on the first speed. And we can see what our current draw is, about 0.35 amps, 42 watts. You notice the energy usage is incrementing, the watt hours. And that will increment throughout this meter session. You can press and hold the next clear button, which is right here. If you press it, if you just tap it, it takes you to the next screen and you see what your volt amps and your power factor is for this fan. You tap it again, it takes you back to the first screen. If you press and hold the button, it will reset your watt hours, your energy consumption. You see it reset back to 0, and now it's incrementing again. When you're logging data, energy data, you will get the total amount of energy used per logging interval. So that does not increment in your data file. You get the actual amount of energy used per each logging interval, and that gives you the ability to totalize that if you want to calculate your total energy consumption per day, per hour, whatever, using HoboWare, or exporting it to Excel if you want. Let's go to the second speed on this fan. Again, we see our current went up a little bit, and our wattage as well. And we go to the third speed. And again, it's a pretty efficient fan, less than half an amp. So that's how the logger works in meter mode.
We want to configure our plug load logger to log some data from this fan. So we have it connected to our computer, and we have the free version of HoboWare open. And let's click on Launch Device, or we can go to Device and Launch, and we will configure the logger for our deployment. So we ran it before, so it retains the name from the previous deployment, which we called fan. Here are all our parameters. We can choose to include or exclude any of these measurements. We'll just include them all. Statistics are a little bit different with the plug load logger. For those of you who have gone through the plug load training, statistics are determined at each cycle. So it's once per cycle, or every 16.67 milliseconds. So if you select, for example, if you wanted to know what the maximum current was per interval, you could select that, and it will be determined at each cycle. So something to keep in mind. It's a little different than some of our other statistical logging products where you can actually set a sampling interval. We're going to set it to a 5-minute interval, and we're going to have it start logging on a push button. We're also going to give it the ability to either stop when the memory fills, or we can stop it with a push button, and we can also allow to restart again with a push button as long as we have memory left. And let's click it for button start, and then we'll show you what that looks like on the logger.
We've configured our logger for a button start, and we have it on our fan, and we're going to log some data. Again, we were in meter mode previously, and now we want to log data to its memory. So we program the logger, and we have it set for a button start. Now we're going to press the start button, which is right here. Press and hold, and it will start logging. And there's our data. And the logger, you can see at the bottom of the screen, bottom of the LCD screen, it says it is logging. So this is our voltage, our current, our power in watts, energy in watt hours. If we go to the next screen, we'll see our voltamps and our power factor.
I wanted to clarify the battery indication here that I have circled. This has AA batteries in it. The batteries are there strictly to allow the logger to continue logging if there's a power outage. When it's plugged into line power, it is using the line voltage to power itself. However, if you experience a power outage during your deployment and then the power comes back on, as long as you have good batteries in there, the logger will it will continue logging throughout the outage and will record the power when it comes back on, and it will be flagged in your data file as line loss, line resume. There'll be internal events that'll flag those, so you'll be able to see exactly when the power was lost and when the power came back on again. The batteries are not used to retain data. Those are written into non-volatile memory, so those are there whether there's power or not. The other thing I just wanted to show you was, you see next to the button, it's just next now. It's not clear. When we're using the logger as a meter, we have the ability to clear the accumulated watt hours by pressing and holding that button. When you're logging data, that will continuously accumulate energy consumption until you offload the data and restart the logger. So that's how the logging mode works differently than the meter mode. The meter mode gives you the ability to reset your accumulated energy consumption. When you're logging it, you do not. It always increments on that screen, and it will be in watt hours until it hits 1,000, and then it will switch to kilowatt hours. We've recorded some data on our plug load logger from our fan over a period of time, and now we want to read out that data and look at it. So we're going to click on readout device, the readout device icon. You notice the file name is fan_0. The reason that is because I already have a file in here called fan.hobo. So HoboWare will do that to make sure that you don't accidentally overwrite an old data file with a new one. If you were saving this in a different folder, it wouldn't put that _0 in there, provided there isn't a fan.hobo already in there. So I don't really care about overwriting this file, so I'm just going to click on it and go ahead and overwrite it, and it'll ask us, you want to replace it? Sure, I do. So we're in our plot setup screen now. Here's all our selected parameters. I also want to include my statistical current, max current per interval based on that 16.67 millisecond sampling rate. I am going to deselect the internal events for now, just to keep things clear in the data file. What you'll see, these internal events include when the logger was started, when the button was released to start it, if the line was lost, in other words, if you lost power, if you resumed power, when the USB host was connected, things like that, and those are all time and date stamped. So let's plot this data, and you can see here's our data. We changed speeds a couple of times during the deployment, so that's why you see this little increase. One thing that you'll notice is the first data point, we're reading 0 amps, 0 watts, and that's because we started the logger before we turned the fan on. Keep in mind that the first thing the logger will do when you start it logging, be it now, in other words, starting it with your computer or pressing the button, if you have it configured for button start, it will take one data point at that time. Even with a 5-minute interval, it will immediately take a data point. So that's what this is reflecting, is the first data point I took, the fan was not turned on, and then I immediately turned the fan on. So the next data point shows the load. One thing that you'll see here, this black line is our voltage. And it looks kind of unusual, perhaps, to see it like this, but keep in mind, HoboWare always plots the data for the best resolution based on the deployment. So if you look at the maximum voltage and the minimum voltage that you see during the deployment, it's only a volt or two. So this might be a little bit misleading. Again, HoboWare is just trying to show you the best resolution for that channel. If you wanted to change that, if you wanted to say, maybe I just want to see it from 0 to 125 volts or something, just for ha-has, and click on done, and then you'll see that it's a nice flat line because it really never went below 120. So again, it's something that HoboWare does. And then here's all our different readings, our current, our max current per interval based on that fixed sampling rate. That's not really going to be different than the amperage because the load really isn't changing. It's a constant load. Power in watts, our energy consumption per interval. You note that we're out 8 decimal places. Those are real numbers. Those are coming out of the register. We're not doing any, the register of the chip that's in there. We are not doing any rounding at all for that output, because we realize that energy consumption, people will totalize that over a period of time, which you can do here. We're using a filter. You can get daily energy consumption or hourly energy consumption, whatever you'd like, using the filter. And by leaving all of those digits in there, we don't compound rounding errors. If we rounded it, you would be, as you add these things up, the rounding error would compound and you would end up with a number that wouldn't be as accurate as possible. So we're trying to give you the best accuracy as possible. And our VA and our power factor. And we also see at the end of the deployment we turned off the fan. So that's what we're seeing here.